Hi students, Professor Nugent here. In this video we are going to discuss probit and logit regression models that are a little bit better at predicting the probability that our binary variable equals 1. The problem with the linear probability model is that it models the probability of y equals 1 as being linear in x. We saw in the last video that we can, using the linear probability model the probability that y equals 1 given x as equal to beta naught plus beta 1 times x. But we saw that this has problems at values of x which give us probabilities close to 0 and 1 because we can get probabilities, predicted probabilities that are actually negative or greater than 1. Instead, what we want ideally is for our probability of y equals 1 given x to be increasing in x for positive values of the coefficients, and for the predicted probabilities to be between 0 and 1 for the domain of x. This will require a nonlinear functional form for the probability. So it's going to look something like an S-curve. Alright, folks. So this means that the changes in predicted probability for a change in x are going to vary over the domain of x. Here is an example looking at our mortgage application case where we have mortgages approved equal to 0, mortgages denied equal to 1, and the probit model is predicting the probability that a mortgage is denied, and you can see that the probability that mortgage is denied given x is increasing in x for this positive coefficient. So it is the predicted probability is increasing in the payment to income ratio, and we're not going to see probabilities below 0 or greater than 1 for the probit model. So the probit model satisfies these conditions that we require for an ideal model for our binary dependent variable. The probit regression model will model the probability that y equals 1 using the cumulative standard normal distribution function. Alright? Two important words, cumulative and normal, right? It's cumulative standard normal distribution function. This is the z table. We're familiar with the z table, right? And what the z is equal to is the beta naught plus beta 1 times x. So the probit regression model is equal to the probability that y equals 1 given x. That's equal to the cumulative probability as a function of beta naught plus beta 1 times x, where the cumulative, this sign phi is a cumulative normal distribution function. Z, our z value or z index, is equal to beta naught plus beta 1 times x, and the probit model is going to give us the estimates of the beta naught and the beta 1 that give us an accurate probability that y equals 1 given x. Let's look at a brief example. If we suppose that beta naught is equal to -2, beta 1 is equal to 3, x is equal to 0.4, so that the probability that y equals 1 given x equal to 0.4, then the cumulative probability of this thing is -2 plus 3 times 0.4, which is the cumulative probability of z equal to negative 0.8. So this is this area under the standard normal density function, standard normal density curve, to the left of z equal negative 0.8. Let's look at this on a plot to see what we mean. Here is the cumulative standard normal distribution function. And recall that the cumulative standard normal distribution function gives you the area under the standard normal curve up to the value z. And our value z is negative 0.8. Negative 0.8. So we're going to see something like this. And we're going to have all of this area under the curve here. The probability is 0.2119. So the area under this curve is 0.2119. So the probit model fit this function using the coefficients beta naught equal to negative 2 and beta 1 equal to 3, where x is equal to 0.4, and we found that the probability that y equals to 1 given x equals to 0.4 is 21.19%. Okay. Now, why use the cumulative normal probability distribution? Some of you may be thinking, gosh, this is just making it really complicated. Why can't we just use a straight line for cry eye? Well, the cumulative normal probability distribution gives us that really nice S shape that we want, so that the probability of y equals 1 given x is increasing at x for a positive value of the coefficient, and the probability that y equals 1 given x is between 0 and 1 for the domain of x. This is pretty easy to use because our probabilities are tabulated in the cumulative normal tables and are easily computed using regression software. In addition, it has a relatively straightforward interpretation because we can interpret the function inside the parentheses as a z value, and we are pretty familiar with z values now. We've been working with them for a couple semesters. So what the probit model gives us is the predicted z value given x, and beta 1 is the change in the z value for a unit change in x. In the next video, we're going to look at an application to help us think about what it looks like to run a probit model, what is the predicted probability, and how to interpret these coefficients.